Welcome to MRS Bulletin's Materials News Podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Sophia Chen. Think of your coffee mug. It's made of a conventional ceramic material, which means it's hard, lightweight, and resistant to heat and corrosion. These, among other properties, are why Matt Dickerson of the Air Force Research Laboratory is interested in ceramics for aerospace applications. But your coffee mug is brittle. Drop it, and it easily shatters. To create non-brittle ceramics, one approach has been to engineer the material's structure on the nanometer scale.
You can get ceramics that bend and go back to the original shape with no damage, or you can get materials with near theoretical strength.
These ceramics are made of nanometer scale fibers, so they're known as nanofibrous ceramics. However, it's really difficult to actually manufacture these nanofibrous ceramics into useful objects.
The instruments they use to make those materials aren't particularly great at making large-scale components.
Dickerson's team has come up with a way to 3D print nanofibrous ceramics, which they think will make large-scale components easier to make.
We're able to extrude these polymers into set shapes.
Previously, the typical technique for making nanofibrous ceramics was known as electrospinning.
Electrospinning typically makes non-aligned, non-woven mats of material. So think of a big pile of spaghetti with one spaghetti noodle, and that's what you typically get with electrospinning.
In contrast, 3D printing gives them a lot more control over the shape of the components. In their study, they were able to make a ceramic spring.
We were able to quite easily produce these ceramic coil springs and then show that they could be cycled like 10,000 times within the paper without showing degradation of the mechanical properties.
The technique involves blending two different polymers together. The first type are block copolymers, which will self-assemble into nanofibers. The second type of polymer are pre-ceramic polymers, which turn into ceramic materials when heated.
When you blend them together, the block copolymer will force the pre-ceramic polymers to self-assemble with them.
Then they heat up the blend. The block polymer is burned away while the pre-ceramic material is turned into ceramic. In this way, they can make bigger nanofibrous ceramic components than with other methods.
You're able to produce large amounts of nanofibers at once. The key is in combining it with additive manufacturing.
The material could be useful for substrates for catalysts, for mechanical components like the spring, or battery materials.
We can think of other applications such as insulation, such as seals between high-temperature components.
This work was published in a recent issue of NPJ Additive Manufacturing. My name is Sophia Chen from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org and follow us on X at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.